Hi everyone, Mr. Benjamin here, and today we'll be doing worksheet 1 of the rate of reaction worksheet. So let's read this question together. So the graph shows the volume of hydrogen gas. So the volume of gas here is hydrogen, given off when 2.4 grams of a metal was dissolved in excess hydrochloric acid. So do remember that every time you see the word excess is important information. So circle the word excess and keep that in mind. Right, so when a metal reacts with an acid, hydrogen will produce. So we can see that at the start of the reaction, hydrogen is producing quite fast because the gradient is quite steep. And then after a while, the gradient slows down, meaning that the rate of reaction slows. And then eventually the gradient becomes zero, indicating that the reaction has stopped. All right, so let's answer the questions over here. So we have started with 2.4 grams of metal. The question asks, after how long was 1.2 grams of metal reacted? That means they're asking when is half the reaction. So 2.4 grams of metal produced, 2.4 grams of metal produced a total of 50 cm3 of gas. So if I want to know 1.2 grams of metal, I need to be looking at 25. So we need to draw 125 over here and then draw a line down. And I think we can take anything between 3 or 4. Okay, anything around 3 or 4 minutes is when half 1.2 grams of metal has reacted. Now, after how long has the reaction complete? So the reaction complete when the gradient reaches 0. So I guess it's somewhere around here. Okay, so I can take maybe about 10 minutes, after 10 minutes, around there. Next, the volume of hydrogen gas is produced in half the time taken for the reaction to complete. So half the time as compared to half the metal is different. So the total time is 10 minutes. So now we're looking at 5 minutes, somewhere in between. So if we draw 5 minutes and we draw a line up, that would be approximately 30 cm3 of gas. So that means half the time 30 cm3 of gas, the first half of the time produced a lot more gas. Right? So now we are going to describe the rate of reaction as the reaction proceeds. So we'll start reaction starts fast as the concentration of reactants is high. So when we first start the reaction is very fast because the reactant's concentration is the highest, right? As reaction proceeds, reaction slow down. As concentration of reactant decreases. So now I've explained it started fast, then it slows down. Now I need to explain when it stops. Eventually, rate of reaction is 0. Reaction stops as one of the reactant is used up. So we need to determine which reactant is used up. So that is why it's important for us to circle which one is in excess. Excess hydrochloric acid means that the metal is limiting. There is lesser metal than acid. There is too much acid. So that means when the reaction is over, the acid will be left behind, excess, and the metal was reacted finish. So the reaction will stop when all the metal has reacted off. So the reaction stop as metal react finish. Okay, so over here, reaction starts fast because concentration is high. When a reaction proceeds, reaction slows down because concentration decreases. Eventually, reaction stops because limiting reactant, sometimes can be the acid, sometimes can be metal, but in this case, the acid is in excess, so the metal is limiting. So the metal react finish. So that's your 3 marking points. Let me label it one more time for you. Start fast, concentration is high, slow down because concentration decrease, and reaction stop because the metal react finish. All right, okay, let's look at the last 3 questions. So on the graph above, the curve changes depending on the situation. So the acid is diluted. Diluted means concentration decrease, but it's still in excess. So when we draw the graph, we are always looking at 2 parts. We are looking firstly at the start. This is the gradient, which is the speed. And then this is the volume of gas, which is how much is being produced. Okay, so over here, the yield. Over here, I've used acid that is diluted, but it's still in excess. So diluted means that the rate of reaction will decrease. So that means the starting gradient has to be slower. Means the starting gradient is below over here. The one in red, slower. But the ending point would still be the same. Because the acid is in excess, the volume of gas produced is still the same. So the starting is gentler, the ending is the same. So then we'll join the 2 lines together. And then we have a graph that looks like this. So gentler at the start, but ending at the same point. So we need to label this as B. Okay, let me use another color for the next one. Let's use blue. Okay, now 1.2 grams of metal is used. So I started as 2.4 grams, now I use 1.2 grams. That means it will produce half the amount of gas, which is at 25. So the ending point is at 25. Right? The 4 factors that affect the speed of reaction is concentration, temperature, pressure, and particle size. But the mass of substance doesn't affect the rate of reaction. So the rate of reaction should remain the same. So you can see over here, it's the same gradient. So same speed of reaction, but ending at half. So I'll draw the same gradient and then ending at half. So this is how the second graph will look like. This is C. Okay, same speed, but ending at half because 1.2 grams is used. Last one, the acid is warmed. So that means become hotter. Temperature is faster. Alright, so temperature is higher, speed of reaction is faster. Let me use another color. So faster means gradient is steeper. So I can draw one gradient like this, steeper. Right, you see the green line is more steep, means it's faster. But increasing the temperature wouldn't increase the volume of gas being produced. It just produced faster. So the ending point is still the same. As you can see at the top, the green line is still at the same point. So it goes up and then it joins back at the same level. And then this is D. Okay, so I hope this worksheet number 1 is okay for you. Please try the next worksheet before watching the next video. All right, all the best. Bye.